Space is full of wonders. Vast nebulae glow with colors unseen on Earth, galaxies spiral through the cosmos, their arms filled with billions of stars. But few objects in the universe capture our imaginations quite like black holes. These cosmic entities are shrouded in mystery, they are invisible to our eyes, yet their influence is undeniable. What if we could actually see a black hole? What would it look like? Would it be a gaping void in the fabric of space-time? Or would it be something even stranger? Something that defies our current understanding of physics? The truth is, seeing a black hole directly is a challenge. Their very nature makes them invisible to our conventional telescopes. But that hasn't stopped us from trying to understand them. Scientists have developed ingenious ways to indirectly observe these enigmatic objects, piecing together their secrets from the faint whispers they leave on the cosmos. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. Imagine throwing a ball up in the air. It goes up, slows down, and then falls back down due to Earth's gravity. Now imagine a place where gravity is so strong that even if you could throw the ball at the speed of light, it would still be pulled back in. That's the kind of extreme gravity we're talking about with black holes. Light, which travels at the fastest speed possible, gets trapped within this gravitational grip. Since no light can escape, we can't actually see a black hole in the traditional sense. It's like trying to see a black cat in a dark room. You know it's there, but you can't make out its shape or features because there's no light reflecting off of it. However, just because we can't see black holes directly doesn't mean they are completely invisible to us. Their immense gravity leaves telltale signs, distorting the space and time around them in ways we can detect. While we can't see a black hole itself, we can observe its effects on its surroundings. One way is by looking for the shadows they cast. As light from distant stars passes close to a black hole, it gets bent by the intense gravity. This bending creates a dark region, a silhouette of the black hole, against the backdrop of the starfield. Another way is by observing the behavior of matter falling into a black hole. This matter, often in the form of gas and dust, spirals inward, forming a swirling disk called an accretion disk. As the material rubs together, it heats up to incredibly high temperatures, emitting intense X-rays that we can detect with specialized telescopes. In 2019, the Event Horizon Telescope, or EHT, gave us our first ever glimpse of a black hole's shadow. Using a network of telescopes around the world, the EHT captured an image of the supermassive black hole at the center of the galaxy M87, revealing a bright ring of light surrounding a dark central region. This groundbreaking image provided the strongest evidence yet for the existence of black holes and opened a new window into studying these enigmatic objects. Section 4. A Universe in Distortion, the View from the Edge. If we could see in wavelengths beyond the visible spectrum, black holes would appear even more spectacular. In X-ray light, they would shine brightly as the material in their accretion disks reaches millions of degrees. We would see jets of high-energy particles being blasted away from the black hole's poles, stretching for thousands of light years. But perhaps the most mind-bending aspect of seeing a black hole would be the way it distorts the fabric of space-time itself. Einstein's theory of general relativity tells us that gravity is not a force, but rather a curvature of space-time caused by massive objects. Black holes, with their extreme gravity, create extreme distortions. Imagine looking at a star field with a black hole in the foreground. The stars near the black hole would appear stretched and distorted, their light bent and warped by the intense gravity. Time itself would be affected, slowing down as you get closer to the black hole. It would be a truly awe-inspiring and disorienting sight. Section 5. Beyond the Event Horizon. A glimpse into the unknown. The event horizon of a black hole is the point of no return. Once something crosses the event horizon, it can never escape, not even light. What lies beyond the event horizon is one of the biggest mysteries in modern physics. Some theories suggest that black holes could be gateways to other universes or dimensions. Others propose that they could be the seeds of new universes born from the ashes of collapsed stars. Could we ever see inside a black hole? The answer, unfortunately, is likely no. Any information that crosses the event horizon is lost to us forever. It would be like trying to send a message into a black hole. The message would never be able to escape and reach us on the other side. However, while we may never be able to directly observe what happens inside a black hole, that doesn't mean we can't continue to learn about them. By studying their effects on their surroundings and developing new theoretical models, we can gain a deeper understanding of these enigmatic objects and their role in the universe.